Welcome to the Explainer. Today, we're going to crack open the toolbox of the modern digital world. We're going to look at the engine that turns these huge mountains of data into really game-changing insights. And that engine is Python for data science. Okay, so get this. Every single day, we, all of humanity, we generate an amount of data that's, well, it's almost impossible to wrap your head around. We're talking 2.5 quintillion bytes. That's a 25 with 17 zeros after it. It's just a staggering figure. And believe it or not, it's only speeding up. And you know, this data, it comes from everywhere. The videos you watch, the stuff we post on social media, even our smart cars, and yeah, our refrigerators. It's basically this chaotic digital flood. So the big question is, what on earth do we do with all of it? How do we make any sense of it? Well, that's where this really revolutionary field called data science comes into the picture. You can think of it as the art and the science of taming all that digital chaos and turning it into something that's actually, incredibly valuable. So if you really break it down, data science is all about being a kind of digital treasure hunter. You're sifting through all this massive digital noise to find hidden patterns and genuinely useful insights. It's really about asking the right questions and then letting the data itself show you the answers. And a lot of the time, those answers are pretty surprising. I mean, check this out. It's a classic example. A data analyst at Walmart was digging through sales data and found this totally bizarre connection. What was it? They saw that sales of strawberry Pop-Tarts just shot up. We're talking 7 times the normal amount, right before a hurricane was about to hit. Now that is data science in action. It's all about finding these valuable and totally unexpected relationships. And hey, it's not just about hurricane snacks, right? Data science is pretty much the engine running behind the scenes on so many things you use every single day. Think about it. It's how Netflix just knows what movie you're going to want to watch next. It's how your Google inbox is so good at filtering out spam. Or how Amazon suggests that perfect product you didn't even know you needed. It's just constantly working back there, personalizing our whole digital world. So the people who do this kind of work, data scientists, you can really think of them as detectives. Seriously. They're investigating leads, they're searching for clues, all hidden inside the data. And they're trying to solve a company's biggest problems, or maybe even uncover its next huge opportunity. All right, so what exactly does this data detective need in their toolkit? What skills do they have to actually crack the case? Okay, first up, they need a really strong foundation in what we call conceptual tools. This is kind of like their detective training, right? They absolutely need to get statistics to know if a pattern they're seeing is real, or if it's just a random fluke. They use machine learning algorithms to build models that can make predictions, and this one's huge. They have to master something called data wrangling. It's the messy but totally essential job of cleaning up the data before you can even start to analyze it. But, knowing the concepts is one thing. That's the theory. But you need a real practical tool to actually put it all into action. I mean, how do you actually sift through millions, maybe billions of data points and build those models we were talking about? Well, for a massive number of data scientists out there, the answer to that question is a programming language called Python. It has, for sure, become the go-to power tool for taking all those big data science ideas and applying them to solve real-world problems. So why Python? What's the big deal? Well, its popularity really comes down to this perfect sweet spot. It's powerful enough to handle gigantic data sets, no problem. But the way you write it, the syntax, is super clean and way easier to learn than a lot of other languages. And on top of that, and this is maybe the best part, it has this incredible ecosystem of free open source toolkits. We call them libraries, and they're built just for data science. And what that means is you've got this global community of smart people constantly making these tools better, so you're pretty much always working with the latest and greatest stuff. Yeah, you can think of these libraries as like supercharged add-ons for your main tool, almost like power-ups in a video game. 2 of the absolute most important ones are Pandas, which is amazing for organizing and cleaning up data into nice, neat tables. And then there's NumPy, which handles incredibly fast math. Basically, they do all the really heavy lifting for you. Okay, so theory is great, but how do these tools actually turn a bunch of raw numbers into real usable knowledge? Let's walk through a really quick and simple example to see it in action. All right, here's our detective case for today. We've got a real data set here with measurements of head size and brain weight for 237 different people. So our challenge is this. Can we find a relationship between the two? Can we actually predict someone's brain weight just by knowing their head size? So using Python, a data scientist would follow a pretty clear process. Step one, they'd use that pandas library we mentioned to load all that data in. Easy. Then, step two, they'd use NumPy to do some quick analysis. Find the average head size, that kind of thing. And finally, step three, they'd use a simple machine learning model. In this case, something called linear regression. All that really means is it's a way to find the best possible straight line that fits all the data points, which helps us see the mathematical pattern that connects them. And here's the cool part. After running just a few simple lines of Python code, the model spits out the hidden insight. It gives us a simple formula that basically spells out the relationship between head size and brain weight. Just like that, we now have a clear, predictive tool. So, just like that, right? In a couple of simple steps, we've gone from just a messy table of numbers to a genuinely useful model that can make predictions. We literally turned chaos into clarity. And that, right there, is the real power of doing data science with Python. Look, this was just a tiny, tiny glimpse of what's possible here. I mean, from predicting what customers are going to buy to identifying diseases earlier than ever before, the applications are pretty much limitless. So I guess the final question to leave you with is, now that you know a little bit about the tools, what kind of problems would you want to solve with data?